Hey, 11th graders, we are still making our way towards this idea of Voronoi diagrams. So we're getting closer and closer and closer. And today what we're going to talk about is perpendicular bisectors a little mostly, and then just also dealing with equations of perpendicular lines and finding them and how do we apply them and all of that. So let's first of all just talk about what a perpendicular bisector is. A perpendicular bisector is a line that goes through a segment. Here's a segment, and here's a perpendicular bisector of that segment. It goes through that segment at a 90-degree angle, hence the perpendicular, and it cuts that segment in half. So it cuts it into two equal segments, which means it goes through the midpoint, right? If we go through the midpoint, we then cut that segment into two equal pieces. So that's what a perpendicular bisector is that it's perpendicular and it bisects a segment. Mathematicians are not original. We like to give names that describe what it is. So it cuts it in half and it cuts it at a 90-degree angle. There are a few properties of perpendicular bisectors that I do want to discuss with you. Mostly is that the idea is that this midpoint is equal distances from either endpoint here. But we can also say, if I put a point here, this point is equal distances away from, where's my pen? Here it is. Is equal distances away from those endpoints. Let's call those endpoints A and then B. So this point right here is equal distances away from A and B. If I wanted to put a point right here, this point is also equal distances away from A and B. And this is true for any point that you put anywhere on a perpendicular bisector. It will always be equal distances away from the endpoints of the segment that it has bisected. So really, the perpendicular bisector is the set of all points that are equidistant from the endpoints of a segment. It's a really fancy math way to say that I've created a set of all possible points, which is infinite points. Infinite points are what make a line. And these infinite points are all specific points that are equal distances away from two other points. And that is the crucial point for making a Voronoi diagram. We're going to discuss it outside of Voronoi diagrams and not touch it at all in regards to Voronoi diagrams today, but it's going to come in handy. This definition is going to come in handy when we do this later. So make sure that you write that down and have that idea down. This image, I think, is also really helpful for us to understand a few things. So I would recommend having that all down. Also, I would like for you to write down that perpendicular really just means the negative reciprocal slope. Remember in our last notes that we discussed that if we hear the word perpendicular or parallel, all we're really talking about is slope. So a perpendicular bisector, the perpendicular part of that is that we're talking about a negative reciprocal slope, the flip, the complete opposite of the slope from before. And then a bisector means that it goes through the midpoint. So there are two main ideas with perpendicular bisector, perpendicular, and then bisector, and this is how we deal with it mathematically in order to then create equations of lines. Okay, so this is all you should know about it, need to know about it, and then let's go ahead and practice it. So we're going to find the equation of a perpendicular bisector of the line segments whose endpoints are 1, -1, and B, which is 5, -3. What is the first thing you should always do when you're starting a math problem? You should always make sure that you're drawing out visual representations of what's going on. So that gives you these points, just for a second, just be like, okay, well, if this is the idea of A being 1, -1, I can maybe draw my axes like this if I wanted to. Then the idea of 5, -3 would just be a little bit further and a little bit down, and that's B, 5, -3. It doesn't have to be the best graph you've ever drawn. You don't have to label your axes. You don't even have to have a grid. But as long as you realize that this is kind of the visual idea of what's going on, that B is going to be a little bit lower and a little bit to the right of A. And if putting a little XY axis here helps you, awesome. If you don't feel like you need that in order to visually represent this relationship, then you don't have to put that. We want to find the perpendicular bisector of the line segment this. So if I were to just really quickly draw out the idea of a perpendicular bisector, I might connect the 2 points to make a segment. And then I might say like, okay, maybe like something like this-ish. I'm trying to make a 90-degree angle visually, and I'm also trying to make sure that it cuts through in the middle. It's not exact, it's just this idea. But I wanted to draw it. This skill of being able to draw in visually the idea of a perpendicular bisector will come in handy later, okay? So practice this skill now, that when we're trying to think about perpendicular bisectors, we should be able to kind of visually figure out where exactly those lines go. That will help. When we're finding the equation of the perpendicular bisector, we need to find two things. We need to deal with two things, the fact that it's perpendicular and the fact that it's bisector. The fact that it's a perpendicular means that we need to find the perpendicular slope. This is all part of your plan. When we're solving problems, you should have 3 parts: the plan, the solve, and then assess. So the first part of solving a problem isn't even dealing with solving, it's just dealing with a plan. I'm going to label the things that I want to find. I want to find the perpendicular slope because I need that in order to deal with perpendicular bisector. I also, if I want to deal with the bisector, need to discuss that it goes through the midpoint. So that's another thing that you need to find, the midpoint. So labeling that variable that you don't have and putting like a question mark next to it or some sort of indication that you need to solve for it will be a clear visual indication to you that that's something that you need to solve for. Once we have everything visually represented, then we can go ahead and start piecing together what our missing pieces are and try and puzzle this out. So we need to find the perpendicular slope, which means that we need to find the original slope of the segment and then turn it into the perpendicular slope. So the original slope is going to be the change in your y values. So -3, minus -1 will become +1 over your change in your x values, 5 minus 1, which makes -1/2. So then our perpendicular slope is going to be +2. It was negative, so it becomes positive. 1 over 2 then flips to become 2 over 1, or in other words, just 2. Okay, so we have our perpendicular slope, so that's really good. And now we need to find our midpoint. Remember that your midpoint is just the average of your values. So we need to find the average of our x values. How we do that is we add them together and then divide by how many, and then the average of our y values. And that is our midpoint. So these are the only things that we need in order to write an equation of a line. Since we have the perpendicular slope and we have the point that the perpendicular bisector must go through, we have all the information we need in order to write the equation. We're going to do our point slope form. That's your y minus y1 equals m times x minus x1. The reason why is because we have a point and a slope. Y minus -2 becomes +2 equals 2, our slope, times x minus 3. Distribute the 2, and then subtract 2 from both sides. And that is the equation of our perpendicular bisector. So it's just taking a couple things that we've been talking about. Hopefully now you're seeing all of these things coming together, how we find slopes, how we write equations of lines, how we find midpoint. It's all coming together on how we create perpendicular bisectors, and then we're going to be able to apply it here in our next few lessons. So let's talk about a few more IB problems that require us to do these skills. So example number 5. A robot vacuum cleaner is located at point A, which is at 410. It currently cleans by moving along a straight line towards point B. So this is the trajectory of this robot, the little Roomba that's moving across the floor. The robot charging station is located at point E. The vacuum cleaner will have to return to point E to recharge before it reaches point B. It is programmed so that it will turn towards E at point D on AB, such that ED is the shortest distance from E to AB. Find the coordinates of point D. This idea of the shortest distance is talking about something pretty specific. If we were to start drawing in lines, and if I were to say, hey, draw the distance from E to AB, you would probably draw something that looks like this. And you don't even know really what the relationships are there. You just know, like geographically speaking, how you find the shortest distance is you just go straight towards that thing. You want to call this the shortest distance. You want to call like this the shortest distance. It would be this one right here. And the fact of the matter is that the distance between a point and a line is always the perpendicular path to that line. In other words, the segment that shows that distance is perpendicular to the line AB. So that's going to help us figure out a few things. If we want to find where this point D is, we need to find where these two lines intersect, which means we need to find the equation of this line. And if we know that the shortest distance is the perpendicular path from the line to that point, we know that to write that equation, it would have to be the perpendicular slope to AB. And it has to go through the point E. In order to write the equation of that line, we need the slope and the point. Once we have the equation of ED, then we're able to set it equal to AB to find out where actually ED, or where actually the point D is. So I need to solve first for my perpendicular slope. Go ahead and solve for that. We need to find our original slope first. It's the change in your y's over the change in your x's. So 5 minus 10 over 19 minus 4. That's going to be negative 5 over 15. In other words, negative 1/3. Our perpendicular slope is going to be the negative reciprocal, which means it's going to become from negative to positive now. And then 1/3 turns into 3 over 1, or in other words, 3. So your perpendicular slope is 3. Now that we have that slope and the point, we can create the equation of the line ED. So let me just kind of make some sort of notation for me to know and for you to know, hey, this is the equation of the line ED. I'm going to use my point slope form. Y minus y1, which is 3, equals m, which is 3, times x minus x1, which is 6. I'm going to isolate y because I know that in order to solve for this point of intersection, I need to set the equations of the two lines equal to each other. You could put this into your calculator and get the equations of both of the lines and then put them into your calculator and then use your calculator to find the point of intersection, but you can also just do it algebraically. In order to set them equal to each other, I need to isolate for y in order to take one side of one equation and one side of the other equation and follow that process. So that's why I'm going to isolate for y down here. I'm going to distribute the 3 to both of those terms. And then I'm going to add 3 to both sides. Now that I've found the equation of ED, I need to find the equation of AB in order to then solve for that system of equations. We have the slope for AB because we had to find it in order to find the perpendicular slope. And we have a point. We could either choose A or B. I'll choose A. So the slope is negative 1/3 and the point A is 4/10. I could have chosen point B and it would have gotten you the exact same equation. So we'll do y minus 10 equals negative 1/3 times x minus 4. I'm going to isolate for y again because it's the same thought process. If I have y alone, I can then take this part of the equation and set it equal to the other part of the equation and solve for x. I'm going to distribute negative 1/3. It becomes positive because a negative times a negative, and then just 4 over 3. And I'm going to add 10 to both sides. And that is my second equation.